Hey Ann, which has just so much going on, right? But basically is about angles and arcs and maybe a little bit about triangles too. Okay, so on a picture like this, the biggest challenge is being able to look at just part of it at one time. So sometimes it helps to redraw just part of it. So that's the first thing I did. I thought, I want to figure out what angle A is. It's actually the first angle they asked for, but it also seems to me to be just the easiest angle to find first. Which is not always the first. They're not always the same, so it's better to go ahead and figure out everything you can in the order in which it makes sense to you than to try to do it in the order in which you're asked for. I would use these two sides and the arcs they intercept, which is this arc over here and this arc over here. So I just went ahead and drew just that part. I kind of traced it. So angle A has its vertex outside the circle. And the rule for an angle that has its vertex outside the circle is that the angle measure is going to be half the difference between the two. Change. And here's the other. And this 140 minus 50, and then take half of that, which is the same as dividing by 2. So that's 90 divided by 2. So this angle is 45 degrees. All right, so that's the first thing to me that is easy for me to find is angle 1. So that's 45 degrees right there. All right, now, the next thing that I want to find personally, the next thing that occurs to me that I would like to find is this angle up here. It's another one that has its vertex outside the circle. So again, I divided it up into just what I need. I need this side and I need this side. So, and the arcs. So that looks like this. So this is looking for angle C. And the 100 is here. That means from B to D is 100 degrees. From D to F is 140. And from B to G is 50. So I need to put that on here. So here's F. 140 here. 100 here. 50 here. I don't know this part. And so when I'm doing that whole angle is 1/2 arc minus arc, because again, I'm going to use that same thing. The vertex is outside the circle, so the same rule applies. But when I'm doing that and I figure out what two arcs I'm going to subtract, first off, it can help when it just stops like this to continue the side. I have to go ahead and draw it further so that you can see very clearly what's between the two sides of the angle. So this is one of the intercepted arcs, and this is the other. So what I mean is, here is one of the intercepted arcs from G all the way around to D. And the other one, let's see what I can use color-wise. I guess I will use orange. Hopefully it'll show up as different than the pink. Yeah. Okay, so we don't know this whole arc. We do know that we need to find it because this angle is going to be half of this arc minus this arc. So I have to find this arc. Well, so a lot of times what happens when you don't know an arc is you know everything else, either on one side of a diameter or the whole circle. Here's what I mean. The whole circle we know adds up to 360. So if I know everything else all the way around the circle except for just this part, I can subtract from 360 and get just this part. That also sometimes happens on other problems. It sometimes happens not here, but if you have a diameter, then you know that everything on one side of it has to add up to 180, half a circle. So if you know, like, say this part, say if you knew that this part was 100, you could subtract from 180 to get this part because everything on one side of this diameter, everything on half a circle has to add up to 180. But here we don't have a diameter. 50 and 100 and 140 from 360. You can do it like that. You can go 360 minus and then minus each one of those. Or you could add them all up and then just subtract that number from 360, which that's kind of my preference. 140 plus 100 is 240, plus 50 is 290. And if I subtract 290 from 360, I get 70 degrees. So altogether, these have to add up to 360, and they do now. Now, the pink arc is not 140 and it's not 70. It's 140 plus 70. So that makes it 210. That whole way around. So now I'm going to do 1/2. My focus is not good. 1/2 of the bigger arc minus the smaller arc gives me the angle. So that's 1/2 of 210 minus 100. 210 minus 100 is 110, and half of that is 55. So now I know angle C. Remember, when you're watching a video I make you can pause and go back at any time. If I go too fast on something, or you just don't catch it and just want to make sure you understand it, feel free to do that. Okay, now I'm going to start looking at some of these angles that are inside the circle. And what I did here was I made myself a bunch of different drawings of it, or a bunch of copies of it, so that I could highlight just the part. Because again, it's hard to look at just part of it at one time when you got so much going on. So here's what I mean. For instance, see that 100-degree arc? Well, I have an inscribed angle that intercepts that 100-degree arc. I actually have two of them. Here's one. It's angle 11. And so that means angle 11 is going to be half of 100. And then the same is true for angle 14, because it also intercepts the same arc. So if that arc is 100, then each of those inscribed angles have to be half of 100. So this is 50 down here, and this is 50 over here. I'll go ahead and put that back on my original figure. 50 right here, and 50 right here. I kind of wish I could erase the numbers when I put it on over there, but that's okay. All right, let's find another inscribed angle we can work with. How about looking at angle 4? Okay, let's do it on a different sheet. Angle 4 intercepts the 140-degree arc. So that's an inscribed angle. It intercepts an arc of 140. So the angle is going to be 1/2 of 140. So this is going to be 70. Let's see if I have any other angles that also intercept 140. To intercept an arc, that means the two sides of the angle go through the endpoints of that arc. So we're talking another angle where the two sides go through D and F. And it looks like there's another one right here. Whoa. Angle 13 does the same thing. It intercepts the arc that is 140, so it would also be half of 140. So this is also 70. So that gives me this angle here and this angle here. So let's go ahead and put them on our picture. So 13 is 70 and 4 is 70. All right. Let's see what else I can do in terms of inscribed angles. Let's see, what about angle 3? Angle 3, let's go ahead and look at it. I don't know if I printed out enough extra little figures, but I think I did. Angle 3 also is an inscribed angle, because remember, to be an inscribed angle means the vertex is on the circle. So the vertex is on the circle, and the two sides go through the ends of arc GF. If we look back here, we decided arc GF is the one that we had to figure out. I'm looking for my sheet. We had to figure out how big it was by subtracting from 360. So we figured out that GF was 70 degrees, and I didn't put it on my figure. I probably should. So I'm going to go do that. So this is 70, which means that angle 3 is half of 70. So that's 35. Okay. This would be a good time, if you haven't been doing this, to start. If you think maybe you understand something, go ahead and pause what I'm saying and see if you can figure it out yourself. So pause and see if you can find another angle that also intercepts arc GF, because then that angle would also be 35, half of 70. Okay, so assuming you paused and thought about that, now we're unpaused. Another angle whose sides go through G and F. Whoa. Is this angle right here, angle 9. So not only is angle 3 35 degrees, so is angle 9 35 degrees. You see why I did so many different drawings now? Because there's a lot on here. So 3 is 35. 9 is 35. Okay. Now these aren't inscribed angles. I'm about to point out a couple other things. These aren't inscribed angles, but these are it works the same. We talked about this. Other angles that have their vertex on the circle, whether they're inscribed angles or not, they're going to be half the intercepted arc. I'm talking about angles like angle 7 or angle 10 or angle 5 or 15 or 2, because I think they mean for the 2 to be this whole thing or the 15 to be that whole thing. So if you have an angle, like let's say angle 10, whose vertex is on the circle, the only reason this one's not called inscribed is because the two sides aren't chords, but it doesn't matter in terms of finding the measure. If the vertex is on the circle, then it's going to be half the arc measure. So angle 10 measures half of 140, so this is 70. And let's use this same drawing to do angle 7. It comes out this way, so it intercepts the 100-degree angle. So half of 100 is 50. So that gives me angle 7 and angle 10. Okay, so we talked about, I just mentioned that angle 15 is like that, angle 2 is like that, angle 5 is like that. So consider pausing the video now and seeing if you can figure out those 3 angles, angle 15, angle 2, angle 5. Those are 3 other angles that have their vertex on the circle. Okay, so angle 5, vertex on the circle. Here are the 2 sides. Maybe I should use my highlighter. So the intercepted arc is the 100-degree arc. So that means angle 5 has to be half of 100 degrees. So this is 50 degrees. Angle 5 is. Okay. Angle 7 actually intercepts the exact same arc. 7 has 2 sides like this. So the part in between the 2 sides of angle 7 is also 100. So that would also be 50. So 5 and 7 are both 50. So, oh, we already talked about 7, didn't we? Okay, so angle 2. Angle 2, the 2 sides of angle 2, I'm going to see if I can use something else here. Actually, let me pause. It's nice that I'm at home making this video because I'm going to use an old teacher trick that a lot of times I want to use, but I don't have what I need handy. One good thing for showing 2 sides of an angle without marking on the figure is spaghetti. So there are the sides of angle 2. Okay, so the only part of the circle that is between the 2 sides of angle 2 is the 50 degrees. So that means angle 2 intercepts a 50-degree angle. And remember, if your material says subtends, that means the same thing. The angle subtends an arc of 50 degrees or intercepts it. All right, so if angle 2 intercepts a 50-degree arc, then angle 2 has to be half of that, so that's 25 degrees. And then if you look at angle 15, it's basically the same thing, just pointing in the other direction. It also has only one part of the circle between its 2 sides, and it's this part of the circle right here, which is 50 degrees. So it's also half of 50 degrees, which is 25. So this is 25 degrees, and this is 25 degrees. Okay, so everything else here, I think I'm to the point where I'm just going to use what I know about triangles. I'm not going to use circle stuff anymore. Remember that in every triangle, all 3 angles have to add up to 180. Okay? So there's a lot of ways we could use that here. For instance, the easiest is probably angle 3, angle 14, and angle 17. Those three angles, 3, 14, and 17, have to add up to 180. These two, 3 and 14, 35 degrees and 50 degrees, those add up to 85. If they have to add up to 180, all three together, I'm going to subtract that from 80 and get 95 for angle 17. Okay, now looking at 16, 17, 18, and 19. Anytime you have two lines cross, you have two pairs of angle types going on. You've got vertical angles, which is the ones diagonally across from each other, like these two or these two. And you have linear pairs, which is the ones next to each other along a line. Vertical angles are always the same as each other. Linear pairs always have to add up to 180 because one side of them is a line. Okay, so 16, 17, 18, 19, we found that 17 was 95 degrees. If this is 95 degrees, then this also has to be 95 degrees by vertical angles. And these two have to add up to 180, or these two have to add up to 180, or these two have to add up to 180, or whatever. So the only other possibility is going to be 180 minus 95, which gives me 85. So both of these are 85. So that helps me find, now I've got 16, 17, 18, and 19. Let's see what's left. Angle 12, is that it? That may be it. Okay, a couple of different ways I would think of, there are several different ways you could find angle 12. I would probably go with the fact that 13, 12, 13, and 16 have to add up to 180. Okay, so 12, 13, and 16, because it's a triangle, and I'm going to finally draw on the picture now because I'm just about done. That's a triangle, just like the triangle we used over here a second ago, has to add up to 180. So 70 plus 85, and then I subtract that from 180, and I get 25 degrees for 12. And I think that's all the angles you needed. So now let's talk about the different types of segments here. Secants are lines that cross through the circle, or segments that cross through the circle and have points on them that are both outside the circle and inside the circle. So let's think about segments that have points that are outside and inside. CG is one because it's got a part that's outside and a part that's inside. So I'm going to say CG. AD is one because part of it is outside and part of it is inside. And AF is one because part of it is outside and part of it is inside. Okay, just from, I was reading, because it says list the lines that are secants, chords, and tangents. Okay, technically chords aren't lines, but that's okay. Because it said lines, I'm going to go ahead and rewrite these. I wrote them as segments. I'm going to rewrite them as lines. Because there are lines that go through AF and lines that go through A and D. You could do it either way, really. I don't know that you would be counted off. There's only one tangent line shown on this picture. That means a line where it touches the circle in one point and one point only and doesn't go inside the circle at all. So that's line CE. You could also call it line CD or line DE. So that's what I'm putting for that. Now chords are segments that have both of their endpoints on the circle itself. Hey, I still have one to work on. Okay, so let's look at segments that have both endpoints on the circle. For instance, BG, that's a chord. BF is a chord. BD is a chord. Okay, so those are all the ones that touch B. Let's look at the rest of the ones that touch D. D to G is a chord. D to F is a chord. Now basically I've got all the segments inside the circle covered except for one, and that is G to F. So those are all my chords. So let's go back and list those. You probably listed them in the order I drew them, so let's see. We did B to G, then B to F, then B to D. Now these are definitely segments. Chords have endpoints, so they have to be segments. They don't keep going, so they're not lines. B to F, B to D. And then we did the two orange ones here, which was D to G and D to F. D, G, D, F. And then we did G to F. And that covers all the segments that are inside the circle. And that should have you all the way through. So I hope that helped. Check it out. Watch the video. Tell me if you have any questions on that. And I'll see you soon. Bye.